Hey guys, welcome back for another SVSU Math and Physics Resource Center tutoring video. My name is Brendon. I'm going to be your tutor, and in this video we're going to use calculus again with power series, but in this time we're going to use derivatives instead of antiderivatives. So I hope you guys enjoy. Alright, so it's kind of similar to the last video. What we're going to do is we're going to get right into another example when we start out by trying to differentiate power series. So what we want to do for this video is we want to write out the power series representation for g prime of x. Okay, and so to do that we first need to find the power series representation for g of x, and then what we'll do is we'll differentiate the power series. Okay, so then to start out, we need to, just kind of like the last videos, we're going to pull out the 5x, and in this case it doesn't look like we need to pull anything out of the denominator because this is already a 1 here. So then it's going to be 5x times 1 over 1 minus 3x to the 5th. So we already have our minus sign as well, so it looks like our r is just going to be 3x to the 5th. Okay, so we can go ahead and write out our power series from here. So I have 5x, and then our summation as n is equal to 0 to infinity of, it looks like we're going to be left with 3x to the 5th to the n. Okay, and then now we just want to simplify this. So this is going to be equal to 5x times the summation as n is equal to 0 to infinity. And I'm just going to break this up. So it looks like we can go 3 to the n, and then we can have a x to 5n. Okay, and so now what we can do is we can bring this 5 and this x inside of our power series. So this is going to be equal to the summation as n is equal to 0 to infinity of 5 times 3 to the n times x to the 5n plus 1. Okay, so now that we have this, what we want to do is we want to take the derivative of it, right? Because we want to find the power series representation for the derivative of that function. So this is going to be d by d by dx of our power series representation. So the summation as n is equal to 0 to infinity of 5 times 3 to the n times x to the 5n plus 1. Okay, and so what we can do is we can move this derivative inside of our power series, because our power series is in terms of n, right? So and then our pieces that have n's on them, we can pull them out of the derivative because they're constants. So this is going to end up looking like the summation as n is equal to 0 to infinity of, so this 5 can come out, this 3 to the n can come out, and then we're going to be taking d by dx of, it just looks like we have x to the 5n plus 1. Okay, and so then what we want to do is we're going to take the derivative of this. So just like we would take using the power rule, we would just take our power, we would multiply it out front, and then we would lower the power by 1. So this is going to be the summation as n is equal to 0 to infinity of 5 times 3 to the n times our power, which is going to be 5n plus 1, times our term with the x, and we're going to lower the power by 1, so 5n plus 1 minus 1 is going to just be 5n. And so then we could probably do one more step where we simplify this. So the summation as n is equal to 0 to infinity. We could pull the 5 out, but I think I'm going to distribute it through this 5n plus 1 term. So we have 3 to the n, and then it's going to be 25n plus 5. And then we have x to the 5n. So this is the power series representation of the derivative of the original function that we started out, g of x. Okay, and so just remember, if you're taking the derivative, just like when we did the integral example, if you can pull out the terms that are just in terms of n and not x, right? Because our derivative and our integrals are going to be in terms of x. And then so another thing that just to remember is to make sure that your interval is going to be when the power series converges, right? So for this to work, the power series needs to converge, as I mentioned in the first example. And you can also go back to that example if you're wondering how to find the radius and interval of convergence.